Hi, my name is Noah Gift, and we're going to talk about Python command line tools, how to rapidly move together a project that uses the Click framework, builds out a library, and injects those things together so that you can build a useful tool in under an hour. So let's go ahead and get started, and before you know it, you'll be an expert in Python command line tools. Let's go back to this repo here and notice that we can go back to more of a software development style of work. We already covered functions, we covered statements, we showed a little bit of what you can do with Lambda. But if we click here, notice, remember I had this code space. Let's go ahead and click this and use this code space. Now, a good thing to point out is that if you don't have access to GitHub code spaces because it's a paid feature, you could do the same thing with AWS. They have something called Cloud9. You could also do it with Google Cloud Shell. You could do it with Azure. You could also do it on your laptop. I personally like this service, so I pay for it because of how handy it is. But again, here we've got these different things. So what do we need to do to start to build out real services like command line tools? Well, the first thing that I would do is make sure we've got the ability to test our code automatically. So in order to do that, I'm going to go through and I'm going to build out a small library that allows us to write code. So what we can do is we can say make directory, we'll call this my lib, and this is where I would put in some code. So we'll go through here, my lib, and then if I do this and I say my lib, and then I think another person asked about this earlier as well, is that in a library, if you put under init.py like this, that basically it will now read inside of this repo for modules. And so I can just go through here and I can create a file called math code.py like that. And now if I look inside of this, Python can actually import this. And I'll show you how an import works here. So if we go through here and we say def add, and I say I say x and y, and I can say returns back x plus y. There we go. So we've got this. How would I use this? Well, if I type in IPython, we actually need to source the virtual environment, so I can do history here, or source tilde v bin activate. There we go. So basically, if I go IPython, what I can do is I can say from my lib, and this is a nice thing about IPython inside of this code repo, I can now import my function. I can say from my lib import, from my lib.mathlib, math code, import add, like that. And now I just use that function. 2 and 2 is equal to 4. That's it. So that's the point of using the under init.py inside of a directory, is it allows the directory to become a place where you can import code from. So that's the second use, because there's two. There's the initialization method in classes, but there's also the under init to tell a directory it's actually a library for Python. So once I've got this, what's awesome about this is I could start to build out a test, and that's typically what I'll do. Is I'll build out a test for my code. So what I'll do is I'll say test, we'll call this math code. So I'm going to go ahead and say touch test math code .py. And the way, not sure why that happened, but let's go back here. Touch test math code.py. There we go. So in this library, I can basically import this and actually test it out. So I can say I can do basically the same thing I did here. I can say from lib.mathcode import add. So let's go ahead and do that. And then I can just write a test function. And this one says test add. And I would just assert something. So assert, in Python is actually pretty easy to explain if you haven't played around with this. If you say assert that 1 is equal to 1, it's true. But if I say assert 1 is equal to 2, it says assertion error. So it's just a very simple way to test a quality. So what I'm going to do is I'm going to say assert that 2 is equal to add 1 and 1, right? That should be what happens. Now, if I go back here and I say make test, because inside of this make file here, I added this. This will give me the ability to test whether my code is actually functioning with the PyTest library. Now notice we're going to need to do a couple things here. So one, I'm going to have to add PyTest cov. So we'll do this. We'll say PyTest coverage. This is a coverage module. And then 2, that's not what this is called. This is called math code. So I'm going to say I'm going to test my lib, which would be the whole library, my lib. And then this one will need to run the right test file. So we'll say test mathcode.py, just like that. So if I say make test, it says unrecognized library coverage my lib, because I haven't installed that new library, which is this library right here. So how do we do this? Pretty easy. I can just say make install again. And that's why I like using make files, is they allow me to really quickly update the packages in my project. There we go, make test. It says there's a problem because I wrote my assert statement incorrectly. We need equals, 2 equals. Now let's run it again. And it's going to say, there we go, I'm able to test the code. So this is a foundational component to then building actually production quality code, is once you understand how functions work and you know its input, work, output, now test it out by building a little bit of test code and then getting this working with locally. So we've got local integration and then working it into a build system. And so what we're going to do next here is I'm going to check in this code. So we'll say git status, and we'll just add all this stuff by just doing that. And we'll say git commit, adding the basic structure for testing our code. And I'll show you in a second why this is so important for real-world professional software engineers. Got that working. It says we need to do a git pull, which happens a lot. There we go. We do git pull. That's fine. And now we can do git push. Wait, git pull. It's going to say the default strategy we want to do git pull origin master. Let's do this. We're in git hell here. Let's try this. Git pull rebase. Git pull. Okay, there we go. We're merging. That looks good. And now I can push. Yeah, because I had changed this outside of this repo, I had a merge conflict. I fixed it. Now if I go back to this repo, let's just scroll over here. Notice that all that code is there. I have a library now, right? But how do other people know my code works? And this is one of the foundational problems with modern software engineering, is that, yeah, you wrote some code, but does it even work? And this is really a problem. And so what we can do here is fix the does anything work problem by going to actions. And if we click on actions, we can go to this section and notice that it gives me inside of GitHub Actions. Again, let me just show you how to do that. You just go here, you click on actions. Look, it says you can build, test, and deploy your code. And that's exactly what we want to do. Building in Python would mean installing the packages. Testing our code would be what I just did. And deploying our code is later if we wanted to deploy this to AWS or Google or Azure or your own data center. Very trivial. Why is it trivial? Well, because if we look down here, notice that they've got recipes for this, right? So deploy your code to the Alley Cloud, deploy your code to Amazon, deploy it to Google Cloud, deploy it to IBM, deploy it to OpenShift, right? These are all, all of these different integrations here allow us to do these kind of cool things. So if you have some time, definitely I would recommend playing around with all this stuff. But what we're going to do is we're going to set up our own build project with a make file, right? And you can see it looks kind of like this, but we're going to just test in our code here. So I'm going to say just kind of copy this a little bit. So we're going to say install. We can see here we don't need that step. We're going to say take this out, and we're going to say install dependencies. We're going to say make install, right? Because that's the command I had. And now we're going to run the tests. So we'll do that. We'll say run tests, right? And so you can see here now we've got pretty simple to make changes to code, right? Make file continuous integration. Let's go ahead and commit this. And if we go over to actions, what's going to happen is it's going to do an install and it's going to do a test, all the stuff that I did locally. And this is really, really useful when you're building real world Python projects, because not only do you have now a more reliable process, but other people that are working on your code have a more reliable process for working with the stuff that you're building. There we go. Uh-oh. Look, it says no rule here for run make check. Okay, we messed something up. Let's go ahead and let's fix that. So if we go back here, we can actually take a look at that. And here we go, make file. So what did we mess? There we go. See, that's the problem, is this is the command that we're running. Make check is not something I have in my make file. If I go back to my make file here, notice that we have installation, we have test, and we have lint. So we need to fix that. So pretty easy to fix. I just go back to my code, go to Github Actions here, and take this Github Actions and fix it. There we go, make test. And once I do this, it will start the job again. And now we have the ability to test our code, and this should pass. There we go, we updated it, we're building it, and let's take a look. Setting up the job, installing the dependencies. So we're now actually getting the ability to figure out whether our installations work as well, which is really, really useful, is to not just test whether the code works. There we go, everything works. But we can also test whether installations works, which really comes in handy if you're building command line tools, which is what we're about to do. So let's click this button here, which says create status badge. Let's copy it and let's put it inside. Here we go. Now that we've got this going, a couple other things that before we build out a command line tool, I'd like to bring up, and that is that we would want to actually lint our code as well. So if I go back here and I say git pull, this will pull in the GitHub action changes. Now notice if I look at the make file here, that there's a lint as well. And so this is how I run it. I say --disable equals RC. So basically get rid of annoying messages and just show me messages I care about. And in this case, I'm going to say, I just want to care about my lib, right? And so let's go ahead and run this and see if it works. We'll say make lint. And no, because I called it imlib, we're going to call it mylib. There we go, mylib. There you go. Your code is successful. Now, let's see what happens if we mess it up. So if I just put something weird in here like this would screw it up. There we go. Right. So we can see that you can't do that. You don't want to redefine a variable, and in fact, there is nothing inside of this as well. Like it's just bad code, and so this blew up our code. If I then run it again and comment it out, it works. So that's the point of linting, is it's another layer of testing as well. So let's go ahead and do this, git add star, and we'll commit this, adding lint. So once we've got this all set up now, we're pretty much ready to go. We can click back here, watch it run, and we have linting. Well, now how do I add this into the build process? Again, I just go through here to the GitHub workflow, and I could even edit it right here in this interface, and I just add another line that says, okay, run the tests. Okay, now let's actually run lint. Let's actually run lint, and let's do that. Make lint. There we go. So, and you can add as many of these steps as you want. Again, like a deploy or whatever. There we go. We do the lint. Does it work? Perfect. Really, it's can't be overstated about how useful this is to be able to know your code is high quality. And it's amazing how many people don't do this, and then they have problems with things not working, and then they're debugging their code for a week, when all you have to do is do these things, do the installation, do the lint, and do the test, and you'll solve so many problems before they even crop up. There we go. We got everything working here. So let's now build out a command line tool here now that we've got this functionality in place. So what I'm going to do is I have another repo called Click Cookbook. There we go, right here. And so I can just steal some ideas from this. So this is a repo for recipes for building command line tools with Python Click. Okay, well, what do we got here? So let's look at maybe an example of something I built with Click. So you can see how Click works is that you put a decorator on top, which we've already covered, and you put some kind of an input on top of here. So what I can do is just basically copy some of this code and just maybe clean it up a little bit. So I'm gonna just literally copy this, and I'm gonna go back to my repo here and just make a CLI. So we'll say touch CLI.py. Now, since we already have that library, let's use the library as well. So I'm going to take out this make change stuff. We want to do something different. And all I need to do at the top here is, remember we covered this at the very beginning, where you do a statement, and you can do, if you make this executable, no one even needs to explicitly call Python. So let's first get that out of the way. So let's do chmod plus x CLI. There we go. So that works. Now, if we run this, it won't work, but let's run it anyway. Right, boom, it blows up. We got a problem. So we want to do a function that's an add function. So we want to say value x, and then we want to build another one on top of here. So we'll just say this would be, we don't even need a prompt actually. Let's just get rid of that. And let's just say first number to add. And then let's add a second one here. Let's add another option, which would be value y, like this, and would be second number to add. And then we can just build this. We just say adds two numbers together, adds two numbers together. There we go. And we'll say, call this add this, and this is going to take in the value x and then value y. So what's interesting about this is that this is actually magically passed into the function here. And that's how the Click framework works. So it's pretty straightforward. You just say click command, you add in whatever one value is, you add another value, and those get passed into the function that does all the work. So what we can do is we can say results, and now we need to import our library. Remember, we had math code, so we can go through here and we can say from my lib import math code. And what we're going to do here is that we're going to take these two values, and we'll actually say the change, or in this would be, sorry, the math code here. We say math code result is equal to math code of, and we'll make sure these are ints. So we'll say value x, and we'll say int value y, so that they're not interpreted as strings. And so this is great. We got this working. And then we would say click.echo, click.style, and we would say this would be the results, the total, and we would say result right here. And that's it. And this would just make it into a red background. And I can get rid of the rest of this. There we go. And so now I just change this to add this. So for me, at least, I like to just take existing code examples if it's a framework and just kind of crib it and make it into a new thing. So let's try this out now. So we have, I think, everything working. Now, I can use my own advice and use lint. So let's go ahead and do that. Let's change the makefile and let's add mylib and also CLI. And let's just make lint this and make sure that I'm not getting myself into trouble. So we go here and we just say make lint, and this should give me the ability to, math code is not callable. There we go. We already have a problem here. So let's fix that. Thank you for that. Could have taken me a while to debug. So from mylib dot math code, import add. That's the problem. We need to do that. There we go. And then inside of here, that's right, that was a module that wouldn't work. There we go. So see, we can see how linting just saves you a lot of time. Let's go ahead and say make lints. There we go. Got perfect code. So let's run this now. We'll say CLI -- help. What happens? It says adds two numbers together. Okay. So first number to add, second number to add. Okay. Well, let's try it out. So let's do CLI value X is 2, and we'll do value Y is 4. What happens? Add this, got unexpected argument value X. Okay, so this caused a problem in that I think we need to make this simpler. We'll just call this value X and value Y. It didn't like the way we did that. So we'll just change this. We'll just say value X and value Y, and we'll do this, value X and value Y. It's a little bit tricky because that framework is so fancy that it doesn't handle the uppercase well in the options. So let's go through here, and we can do value X and we can do value Y. Now we could also write a test for this, which would be a great way to clean it up. There we go. So we got total of 6. Now we don't need the comma right there. So we could put the comma or the colon right here. There we go, total 6. And now if I go through here and I try different things, we can do a big one, 200, and we can do 401. There we go. Now we got a cool command line tool that adds things together. And again, everything's a function here, right? So we see this is a function. These are functions, right? These are just decorators. Right here, mathlib, that's a function, right? Everything's a function. Let's go ahead and clean this up. So let's push this in. So we'll say get status, get add CLI, get add makefile. Let's push this to GitHub. Let's say adding CLI, and let's go ahead and see if this runs. And if it does, we're going to be in great shape here to go to the next step. Okay, and let's look at this. Here we go. Here's our change here, which, oh, whoops. Again, we got to do the git pull. I was like, didn't actually change here. There we go. We'll merge this, push this, and it will deploy our change. So as soon as we do the push, what'll happen is that, there we go, there's the merge. We build, and this should go through and now have a little bit more complicated of a task, because it's going to be linting the command line tool as well. And we can take a look at this. We could also write a unit test or a functional test for it as well. Awesome, everything works, we're in great shape. So this is probably a great spot here to take a break as well. And then, yeah, let's just do like a 10-minute break. And then when we come back, hopefully you have a chance to run this code and see if it works for you. Give me some questions about it. And then when we get to the final hour, what we'll do is build out microservices. So I think we should have the time to build out maybe something with fast API, potentially deploy it onto a cloud platform, also run it locally, and that'll kind of get us to the last section. So